Hey everyone, it's me, your Alvis sir, signing in. Today we are in the topic HCF of polynomials. In last class, we have learned how to find out the HCF of monomials, including the meaning of HCF. Today we are going to learn how to find the highest common factor for polynomials. So, are you ready? Let's get started. So, I pick a question from question number 4a in exercise 9.7. This is from, as I said earlier, this is from Excel in mathematics books by our Hukum sir. So let's get started. Here you can see these terms are not monomials. Why? Because in this term, the variables or the numbers are separated by plus or minus. If any terms are separated by plus or minus, obviously there are more than one terms. Like in English, the work is done by space. In the same way, in the case of the algebra, the work of space is done by this plus or minus sign. That's why here is 1, 2. Two terms are here in the first expression. Similarly, here also 1, 2 terms in the second expression. Whereas third 1, 2 minus are there in between, means 3 terms are there in the third expression. So we apply our technique of factorizing the terms one by one, because HCF means highest common factor. So are you ready to go for the first expression? Let's start. So our first expression, altogether there are 3 expressions. So our first expression is 2x plus 4. Now you have already learned the different technique to find out the factors of given expression. So among them, which one you prefer first? Yeah, obviously take common. Means you will try to solve the common in the terms which are present in the given expression. Here are 2 terms, so we want to take the common from first these 2 terms. So one has the number 2, another has the number 4. So is there anything common? Yes, the common is 2, because 2 divides 2 as well as 4. The number that divides both, the greatest number that divides both, are taken as a common. So simply here 2 is common for us and the remaining term is written inside the bracket. So here whenever you take the 2 common, here it remains x plus as it is. Now 2 are 4. That's why 2 is written inside the bracket. Always you divide the term by this common term and remaining term should be written here. Quotient should be written inside the bracket. So this is our first expression. Now let's go towards the second expression, because further factorization is not possible for the first expression. Our second expression is x square minus 4. So obviously what do you think first? Taking common. But can you see anything common in between them? No, because here is x, here is no x, here is number 4, here is no any number as a coefficient. So definitely there is nothing as a common. So we'll have to think the another way. The another way is that whenever there are the 2 terms, then there is a high chance that there may be the using formula technique may be applied there. That means it looks like some formula. Which formula it resembles with? Any idea? Yeah, that's correct. That is 4 is also the square number. That means 4 is 2 square. So it looks like a square minus b square. A square minus b square. And which means a plus b, a minus b. So let's break in that form. X square minus 4 means 2 square. And which is ultimately it becomes x plus 2, x minus 2. Now let's go towards the third expression. In your question, if there are only two expressions, then you do the two expression and you find out the common factor. But if there are three expressions, then obviously we have to go towards the third expression as well. So if you go to the third expression here again you think in the same way. First of all, you search for the common. Is there anything common? Anything common? Everyone wants here. Is there anything common? Definitely not. Similarly, can you use any formula here? No. But here, whenever you see the three terms, then what comes in your mind? Yeah, splitting the middle term. So let's try the splitting the middle term technique for it. So for that, let's take the expression x square minus x minus 6. Then as you know already how to split the middle term, from the name only it is clear that we have to break the middle term. So let the space given for the middle term and let us put in the format. Here in this format, you copy others as it is, and the middle you leave the gap, others as it is. Now you have to think in such a way that, and this minus sign remains minus here as it is in the bracket. The last sign always should be written inside the bracket. Now you have to think on multiplication 6, on subtraction, what is our previous expression? Minus x only, means we need 1 at the middle. So for that, what would be the number? Search and tell me. Search it. On multiplication 6, on subtraction 1. Any possibilities? Do you find it? Yeah, that's correct. That is 3 and 2. 3 2s are 6. 3 minus 2 is 1. Now it's time to open the bracket. So minus 3x minus minus plus 2 into x, 2x. After this, take common from first two and last two. So what is common from first two? Definitely x is common from first two, and from last two, 2 is common because 2 divides 6 also. So that's why inside the first bracket it remains x minus 3. Whenever you take the 2 common, x minus 2 3 are 6. That's why our second term contains x minus 3 in the bracket. Now the bracket term are same, that means you are in a right track. Among these two brackets, we take one as a common and remaining in the other bracket. So x minus 3, x plus 2 is our final factorized form of our third expression. So in this way, we are able to factorize first expression, second expression, as well as third expression. Now it's time to find out HCF, highest common factor. So first of all, you will see the term out of the bracket first. What is out of the bracket here? 2. What is out of the bracket here? Nothing. What is out of the bracket here? Nothing. So from outside term, there is nothing common. Sometimes here it contains 2, here it also may contains 2, it also may contains 2 outside of the bracket. Then we have to take 2 as a common factor. But right now there is no any coefficient or no any numbers, no any terms outside the bracket. So we simply start to observe the bracket terms. So what is inside the bracket? X plus 2 for the first expression, x plus 2 x minus 2 for the second expression, x minus 3 x plus 2 for the third expression. So among them, which one is same? Obviously, x plus 2, x plus 2, x plus 2 is same in all three expressions, and that's your highest common factor because there is no another common factor. That's why this single factor is considered as a HCF of this given expression. In this way, we are able to find out the solution of these kinds of the polynomial terms. This is your answer, and copy this in your copy. So today we learn how to find the HCF of polynomial terms. We'll meet on next class. Till then, I'm your Albisa signing off.